So, so basically today's session was supposed to be on Dappers. And yeah, there are a bunch of people who said they also want to learn containers and understand what is Kubernetes and then probably going deep into Dapr. So that is, so we have just deviated from the agenda which we had today. But I'll go in, I'll spend 15 minutes on this, 15 minutes, and then probably go in depth into Dappers which we have, right? So cool. Before I go in depth, I just want to introduce myself. I'm senior cloud advocate at Cloud and AI engineering team. Did a bunch of things in my career. There's a bunch of list of things, by the way. So, I was a software developer at IBM, solution architect on DevOps, been head of DevOps at BlackBuck, and been a co-founder and spent some time in developer advocacy in DigitalOcean, and yeah, into marketing and strategy and investment stuff, and then now back to engineering. So I'm a technophile, right? So I like, I know, I like to work on technologies. I like to learn new technologies and share the technology learnings with the community. And if you want to connect with me, this is my digital coordinates. You can connect and ask questions if you have any questions related to anything, career, anything. Okay. Cool. So I just want to quickly run through, you know, specifically on containers, right? And just want to share a couple of things. How you write code. If you take 10 years back, the way we used to write code, I used to write something like "Hello World." Right? Yesterday also I talked about it. Right? We all have written code in "Hello World" in any programming language. Now that "Hello World" I have written, it's on my laptop, and I want to share it with you. Right? Say if I have written that "Hello World" in Java 8. Okay, I've been using Java 8 SDK, and you are using some Java 11, and I have written "Hello World" code in Java 8, and I have asked you to run this "Hello World" code in your machine, and you go there and you try to run, and Java 11 does not support something, and it will fail, and it is asking you to go back to Java 8 to run this code. Now the challenge is you can't go back because you have so many other things you have written in Java 11, right? So now that's the complexity which we induce, right? That is the complexity we create in a development environment, right? There's no portability of code. It's not so easy to port code from one system to another system. Imagine the same issues you get when you port something in production like this, right? So as a DevOps, you always get to hear all these things, right? Now developers will come and say code was working in my system and it doesn't work in your production. You have done something wrong. So it's always that DevOps engineers get all these kind of messages, right? So that's the point. So basically, how do we solve that problem, the portability issues, and how do we make sure that a developer has the same environment as a same environment as the production environment and other things, right? That's where the containers came in, and they said, okay, we will create one layer above your libraries, the kernel which is there, and what we do is all dependencies can be packaged. So code is obviously packaged. Even before we were packaging code, it's not like that, like we were not packaging the code. So we were packaging the code. If I have to share the Hello World code with you, I have to package it and share it someplace like OneDrive or Google Drive or give it to you, and you will obviously download it and then run it, right? It's not like I can't share it without having a single repository, right? So similarly, the packaging was done, but packaging we were not doing with dependencies. We were just doing the packaging. Now, as containers and as Docker, which is an automation platform, which is nothing but a Docker is an automation platform for packaging stuff. It's like you're packaging something with dependencies. So that is Java 8 is my dependency, right? my code is written in Java 8 and I want to package it with the dependency, and I package that and give it to you, and you don't have to be worried of with your 11 Java 11 which is running, because I packaged my code with the dependency. So whenever you run this code, it will run with the dependency, right? So that is what the containers trying to solve, and that's what it solved. Great tool for us, and there are a bunch of things here. When you package something, you create a static representation of your application. You create a static representation, right? So it is nothing but a file, right? And when you package it, you just share it with someone. That is what it is called as images. And you would have heard in Docker world or containers world, images, images, images. People will be talking about images and other things. So image is nothing but a package of application. Your app is running my hello world code in any language. It is running, and I have packaged it as an image with dependencies. So if it is my Java code with Java 8, I'm packaging it and calling it as an image. And if I run this, okay, if I go out there and run this image, then it is called as container. Okay, so containers are nothing but runtime execution. It is running, and images is nothing but static ones. Okay, so that's what you know. Difference between these. There are a couple of things which I'm going to show you now is kind of diagrammatic. Um, there is, if you see here, all these images are stored in the registries. So registry is nothing but a repository. Just like I explained you, right? I have the code, I package it, and after packaging it, what I do, I just have to share it with you, right? So how do I share it with you? I need a repository. Just like your OneDrive or Google Drive, I need a repository. But this is specific to containers. It is about it's about privately accessing it, and it's all about version management of this. It's versioning, right? I could just say hello world today and share it with you, and next within 10 days I'll say hello Vivek and share it with you. So there's a version 2 of it, right? And you want to use version 1 or 2, it's up to you. But again, you need to have a repository for that, right? So you need to know which version to pick. So that is where the registry comes into picture. And there are a bunch of things. You can have private registries, there can be a public registry, and various other concepts, but I won't go into deep into that. So every system, so before creating the package, I need to make sure there is Docker host, which is Docker daemon is running on my system. Okay, if you see this diagram, there is a Docker daemon which is running on your system. You just need to install it. Okay, once you have installed it, you can run bunch of client commands, which is build, pull, and other things. There are a bunch of commands which is there from Docker, and if you run that, so basically, if you do a build, it will build it into an image. So this is done through a Docker file. There is something called as Docker file, and Docker file is a steps. Basically, you provide some steps for how to package. You need to provide steps, right? I just having a .java file doesn't work. You need to you need to run, Java compile, and then you have to package it into a jar file, and then use that jar, right? So that's how you use Java. In Java, if you're using Python, it's a simple Python file, but you also have requirement.txt, right? Which is having the modules and other things. So you want to package it as that as well, right? So basically, there are a bunch of commands which you can run, and this will get converted into an image. And there is containers which is running. Containers are nothing but which is a running image. So this, if you run my hello world, image, that becomes containers. That is running containers where you can access and you can send business transactions, where you can run it and see hello world. And image is just a static representation. So it downloads from the registry into your Docker daemon, and it keeps the image there. And whenever you run containers, it is accessing that, right? So this is about brief introduction. Okay, there's a bunch of things there. Okay, there is a bunch of commands you need to go through. There is daemon you need to install and work and play around with it. There's a registry which you can have private custom registries. There's cloud registries, which is Azure Container Registry, where you can use Azure Container Registry. There are a bunch of things which is there, but this is just a brief introduction of that. Okay, so and container orchestration. Now imagine that I have only one hello world, and that is only from my end, right? One instance of hello world. Imagine there are 10,000 people accessing my hello world web app, right? It's difficult, right? I need more instance of that, right? It's like you want to scale, you want to traffic is coming into your web app, you want to have more of that, right? And more of instance to need to be created. How do I manage all of these things? It's just one container which we were talking about, the hello world. It's just one image which we were talking about. But if I have bunch of images, if I have bunch of containers, if I have to scale these images, or if I have to scale these containers which is running, how do I do it? So basically that's where container orchestration comes into picture, where it manages the containers. Okay, that's where Kubernetes comes into picture. So containers is a packaging tool. You package it and you store it in the registry, and from registry you take it out and use it. But that is only single piece. But if I have multiple containers, how do I manage it? Is where Kubernetes comes into picture, and where you do the updates, where you do increase the number of containers running in your infrastructure, and also if you see here automatically updating it. As I told you, if I do a change in version 1 to version 2, what will happen to it? Right? How do you update to 25 containers? You are running version 1, and if I make a change, how do I update it to version 2? It becomes complex, right? The moment it becomes complex, something has to be come in as a management. So that's where Kubernetes comes into picture. And so container management is nothing but basically a process of making sure that there is basically you're organizing and adding and removing and updating containers. That's the only thing, right? It's updating and adding new containers, updating containers, or you're doing scaling the same containers to the highest level. So that's what happening there. So I'll not spend much time on that. I'll just talk about brief about the architecture here. Okay, this is the Kubernetes architecture. Okay, I'm anyways going to deploy an app to Kubernetes while I'm doing the Daprs. But this is a brief introduction to the Kubernetes architecture. There is, if you see the architecture here, there is a master and there are agent nodes, right? There is a one control plane and there is agent nodes, which is also called as worker nodes. Okay, and if you notice here, there's a user at the top, right? There is a user who is, providing the information to the API server, which is like he's setting the desired state. Okay, so it's basically a declarative tool, not imperative tool, where you're just declaring this is how my infrastructure should look like, and this is how how many number of containers I want to run, and this is how you have to run. So basically, you're just giving information on memory, what is the memory size, and what is the container name, and all those declaration in a YAML file. You're going to declare it your desired state. It's your desired state. You are the designer of this, right? Okay, so you provide this information to control plane. Okay, the control plane, which is the API server. API server takes in that information and hand it over to control manager and schedulers to decode your input, and it schedules these containers. Okay, so this whole infrastructure management is taken care by Kubernetes. Just understand that. It becomes really complex if you think too much right here. It's not so difficult. You are giving information to the API to the master that this is how you want it to be. So very simple. If you take this example of this room itself, right? This room we want 100 people to sit here, and we want to do this event. Right? This is my desire. Okay, that is the desired state of mind. I'll say, okay, I want 100 seats. I want to do event here, and this is how I'm going to do the event. I need a screen. I need this. I might need this. I'm not told which room I want to do this. I'm not told them, this is how I want to do this, and these many people only we can schedule, and I'm allow these many people, and they only I will allow, and other things, right? So basically, I've only planned high level plan is there with me, and I'm going to submit that high level plan to people, and they will execute it. The executions are different, right? So I'm not executing it, nor I'm deciding which room to do this event, right? So there is nor you are the decider of which node you are running these containers. You're not deciding it, nor you are deciding what should be the allocation of these memory, RAM. You are just deciding what is the limit I can give. I can give one chair to one person. That is the limit I can give, right? But two people can also sit, right? So that's how communities work, right? So that's how that's the analogy there. So there is control plane, there's user desired state. So user desired state submit to the control plane with API server. Control manager and scheduler will do the rest of the things what it has to do. Except which you see there, except which is nothing but a database, which is having the information about the cluster. What is the cluster doing and other things. And then there are agent nodes and worker nodes. And in agent nodes, you can see kubelets, right? The kubelet is nothing but a binary. Okay, it's a binary where it is executing the task which has been assigned to it from the control plane, which is from the schedulers or control manager, which will inform kubelet to execute this, right? And it is also informing back the state of the node to the master. Okay, so kubelet is the heart of your agent node, which is basically trying to understand what is happening in the infrastructure, and also it is executing the instructions which it is getting. Okay, and if you notice there in the diagram, there is something called as pods, and within the pods there is something called as containers. So in Kubernetes, smallest unit is called pods. Okay, and there is containers which is been running inside the pods. So as I told you, containers are packaged. That's an app, your app, Hello World app. I can have many instances of Hello World app within the container and have pods, run it as a pod, so that I can have multiple traffic come into the pod. Okay, and there's traffic coming into the pod through kube proxy or something, and then containers is getting executed. And you notice that it is called containers here, not images. That means it's an executing ones, right? Got it? So this is how it works. There is bunch of things which it does, and then boom, a complete your script is running. We will see an example anyways. I'm going to show you how this YAML file will look from the user perspective, how you will give the desired state, and then how it executes from the API server, how you want to submit it, and then how it gets executed. Sorry. Okay, I'm going to switch slides now. I'm going to go back to Dappers. So it's just an introduction to containers and Kubernetes, so that we can learn more about Dappers. All these will be connected there as well. Okay. So instrumenting Dappers on Kubernetes. So basically, I'll skip a couple of slides of mine. Oh, okay, this is important. I don't want to skip this, right? So you go and ask anybody, right? As of today, you go and ask anyone. How many of you know what is microservices? 1, 2, 3, 4, 5. So if you go and ask anyone, cool kid, right? And they would say today is everyone is building on microservice. Monolithics are out, right? So I know there is a debate on that, whether I want to go on to microservice, monolithic, and other things. Anything you go, it's microservice or monolithic, right? Either you go serverless, whatever it is, either it is monolithic or microservice, right? So there is definitely a discussion out there, but there's a lean towards microservice, right? Because it helps you solve many problems. Of course, when you build and when you deploy something, when you test something, monolithic is obviously good. But what is the challenge you're going to face in monolithic? So in this diagram, if you see, there's a bunch of challenges you can make out, right? There is one module for a bunch of services here, right? There is identity, there is catalog, ordering system, basket. It's basically so it's like a e-card, right? Your Flipkart kind of a tool. And there is one database which is there, and there is one API or mobile app API service which you have. So imagine you did some changes to basket service, and you go as a developer, you always make mistake, right? And you make the big mistake of crashing a system. You go there and you make changes to basket, and what happens to your complete service? Complete service crashes because it is all together, right? It's been bundled as one unit, and as a business, you can't afford to lose all the service, right? Say, for example, you are a e-card which is selling a book, right, online. It's okay if the review is not working. It's okay, but it's still I can if I'm able to buy the book, it's still fine, right? If the review service is not working, it's okay. But if I'm able to buy the book, it's still fine, right? So that is what that's what microservice actually solves the problem. But there are a bunch of other issues as well. This is all code dependent, right? So if you see the basket service, I might not use relational database. I might use different database, right? I won't use the same database. It's a kind of different database which we are going to do. And there is order, for ordering, I'm going to use relation. Maybe probably for basket, I'm going to use Redis. There are different databases, and instrumenting that here is very difficult. And you need to remember what did you instrument, for which one, which instrumentation you did for from a database perspective. A lot of other things like this is written in Java, and I want to move it to, I want one of the service to be in different, probably in Python. I can't do it here, right? Because it's completely written in Java. So I can't add a Python service in between, right? You can't do that in a monolithic approach. So this basically is a microservice approach of the same thing. Okay. Now, if you see here, there's an API gateway, and there are different set of clients who are accessing via the API gateway, and there is a bunch of databases for different services. Each and every service has its own databases. Okay, so if you see here, the ordering service, the basket service has its own database. So it means basket service will be using Redis, the ordering service will be using relational database, anything like MySQL or anything, or the other one is using something else, and it is all talking with each other with event bus, with publish and subscription model. They're all talking to each other through that the last layer, which is the event bus, where you publish the conversation and it picks up the conversation and it sort of returns the conversation back, right? All of these are talking to each other. All of these are really great, to see, and obviously this looks amazing. AI solves a lot of problems. Yes, it does. True. And easy to manage this, easy to do the CI/CD, easy to deploy code. If one service fails, other service is running. You can easily see which service is failing and everything. But it is very difficult to manage this. Okay, it adds a lot of complexity. Okay, so couple of challenges it adds. One is obviously how does each service discover itself? Right? There is a discovery issue, and you need to make sure it is discovering each other. Otherwise, they will not be able to talk to each other, right? So you need to make sure that is being handled. And how does each services send messages, and how does resiliency work? You know, resiliency is so one service A and service B, there are two services, and if service B fails and service A is still trying to reach service B, and it is trying that request for more than 30 times or 30, 40 times, how does, what is should be the response for the customer? Whether you will say five not three or some error message, or you're going to say, okay, not use operations and say busy server or something like that, right? So how do you handle all these kind of failures? Because failures are going to happen to each and every service which is running, right? So the service is going to fail for sure. There is no 100% always running service ever been built. So service is going to fail, and when service fails, what happens to the other service which is waiting for this particular service? And how does it handle the things? There are a lot of concepts called as circuit breakers and various other concepts, right? So how do you handle all those things? And what about observability? You have 25 services. How do you see the bottlenecks in these 25 services? How do you trace performance of these 25 services? Like we could talk to 20 services. One request can talk to 20 services. That is how the complex the systems are. So if they talk to 20 service, now where will you find the performance issues? How will you find the performance issues? So all of this got introduced when microservices came into picture, and there were a bunch of tools which came in to solve this problem. So there are a bunch of tools which is solving this problem. So what Dapr does is, so Dapr addresses this challenge. Okay, so as I told you, there are a bunch of issues and all of these complexities which is introduced in microservices. That's where Dapr comes in and solves this problem. And the way it instruments is just amazing. So I'm going to show you how it instruments now in the demo, and you will see that how amazingly it instruments this particular complexity. It is very complex to build something in microservice with all of the tools which is there, because you need to instrument it in your code, right? It's basically code instrumented, and I will anyways discuss about it. So Dapr is nothing but distributed application runtime. So it's basically open source tool as well. So you can make use of this, and I'll just go next. Okay, so it has a couple of things. So there is, you can write code in any of the languages, and it has a support for all of these languages as well. And then via the HTTP API or the remote procedure call, which is there, Dapr has a couple of building blocks. I'll talk about these building blocks in depth, but this is having a couple of building blocks out there, and it can be used on any of those infrastructure which is out there. So, so what it does is it's basically it's kind of a platform, a tool, where it helps you on the fly solve a couple of issues with respect to microservices. And we'll talk about that issue in depth here. It's a building block. It's called as building blocks in Dapr. And if you go to the Dapr site and see what our building blocks are, and these are the building blocks of Dapr. And what it does is, there are a couple of things. One is service to service invocation. This was a problem, right? How do I find different services, right? This is, it's what it solves. And state management, what is state management is? Is basically you have long running processes and there are going to be, you need to manage the state of it. So multiple state needs to be stored. Say for example, basket service where you have a cart, right? And you add things in the cart. It's nothing but you're managing the state there as well, right? And you want to use, probably today you are using Redis, and what about, you plan to use something else instead of Redis? You will have to instrument it in the code. Because today, the problem is if you're going to, without Dapr, what you will do is you will write code for it. You will have to go and add it in the code in your Python or Java, any code you take, you have to instrument in the code. With Daprs, you need to instrument it. That's all is the difference. And
by Microsoft itself, right? Open source
by Microsoft, and it is also part of CNCF. So there are a couple of building blocks, right? The publish and subscribe. There is binding. Binding is nothing but triggering something, right? So there's a bunch of things you can trigger and run through the triggers. And there is actors. Basically, you can encapsulate data and the usable content, and then you can use it as well as an actor. And the observability, today's example, I will show you how to build with observability, how it was before Dapr and how it is after Dapr, right? So we will see that. And then there is obviously secrets and configurations you can do. So basically configurations, so you make changes to your configuration, infrastructure. When you make changes to infrastructure, somebody has to inform someone, right? That you made changes to infrastructure, right? So all of these things was not available on the fly. There are a bunch of tools. So what are those tools? Bunch of components. Okay. So if you see, these are the building blocks for any microservice. You will be using state management. You will be doing pub sub. You will be doing triggering. You'll be running through a secret management. There is observability as an issue and configurations and management of different changes in the configuration. So there is a bunch of tools which is out there. So individually, if you are not using Daprs, individually you would have done something with all of these things to manage your microservice. And to do that, you would make changes in the code. You go to the code, you make changes, you add their SDKs. Say for example, for PubSub example, let us take publish and subscribe example there. And if you see that in the diagram, there is, I would be using RabbitMQ, right? I'm using RabbitMQ. I'm all fine with RabbitMQ, all good. But I would have 25 different services which is running, and I want to make sure I move towards cloud instead of managing RabbitMQ. I would be managing RabbitMQ as a standalone, so I don't want to do that anymore. I want to move it to the PaaS. And how do I do it? So I will say, okay, I want to move to Azure Service Bus, and I try to do that. Now, if I have to do that, I will have to go and change the code without Daprs. I will have to do it with
RabbitMQ or Azure will do that.
Yes, not Azure. Could be anything as well. You can take anything. You are moving out of RabbitMQ to Redis. Let's take that. Moving from RabbitMQ to Redis, how will you do it? So, it's kind of like you have to go back to code. You meant to make changes in the code, and that's tough. Because imagine you have 25 services, or 30 services, or maybe more, and all of these services you want to make changes from RabbitMQ to Redis. It's not easy because you will have to change the SDKs, you need to add SDKs, and you need to package it again. You will have to see a lot of things. So same thing with observability as well. This is the example which we're going to see as well. There is Zipkin and there is Eggers. You might be using Eggers, you might be using Zipkin, right? And you want to move from Zipkin to Egger. How will you move? It's not so easy, right? Because you have to instrument. I'll show you how it has been instrumented as well, right? So there are building blocks and there are components. Okay, so in a nutshell, what we are doing is you have a primary service, which is your service, which is could be your Hello World, which we talked about. It could be a web app service, which is Hello World, and you want to use it with sidecar architecture. So Dapr is a sidecar architecture. So you know sidecar, right? You would have seen Sholay, right? There is sidecar in Sholay, right? That is what sidecar architecture means. So that means all the request which is coming to your service is going through Dapr APIs. Okay, we are going to add one, one of the service in front of your primary service, where all the request which is coming to your service is going through this Dapr API. Okay, and with different set of protocols out there. And as I told you, there are building blocks. There were main building blocks, observability, and there were other things which is service invocation, right? There were building blocks, right? The ones we discussed, right? State storage, pub sub, building, binding and triggering. All of these are called building blocks. And then there is components. So components can be anything. So imagine you are trying to use Redis cache and Azure Service Bus, right? If you're using both, there is and you don't need to instrument it in the code. You don't have to do anything in the code. Just add dappers to it, and then your dappers will take care of all of these things, right? So you don't need to instrument anything. It just talks to your Redis cache, or it does talk to the Azure Service Bus, both. Okay, so in a nutshell, your application code is talking to API for all of these different building blocks, right? Now, the reason why I wanted you to think about Kubernetes, why I said, okay, we will go through the Kubernetes first before we go into Davos, is because this is how it exactly works. So there is a pod. We did discuss about pod. Remember when we talked about Kubernetes, there is pod which is running the container, which is your application. But if you see here, Dapr is also running as a container. At least one process of Dapr runs as a container, and it is with your container. So both the containers are running. If you run one container for your application, you will add one more container to it, which is for Dapr, right? And all requests for your application code is going through the inbound and outbound is going through Dapr. So what does Dapr has now? Information on your application code, right? Because it is the one which is interfacing. So it is interfacing the infrastructure, right? If you see this, you can see this, right? You can see how it is interfacing the infrastructure. Now it can handle resiliency. I didn't talk about resiliency. There's service A, there's service B, service A goes down, or service B goes down, service A is still trying to reach service B. Now, there is the information that service B is down, and we can't take more, more requests. It will tell service A that, hey, no request from my side. You can stop sending me requests. I can't answer you because we can stop asking these questions, right? So this is how you can build resiliency as well with the Dapr APIs from an infrastructure perspective. How do you manage through infrastructure? Obviously, resiliency can be managed through code as well, but that is a different discussion. Okay, cool. So this is basically just remember in a Kubernetes world, there's a pod running, there's your application running, and there is your Dapr container is running, which is managing everything for you. You are not writing a single piece of code to manage your application code. So let us take an example. So I not go through this. This is about observability. Categories in observability. I'll not go through this as in detail. But I'm going to take one of the examples here, which is distributed tracing. So tracing is nothing but one request. So one request has been traced from service A to service B, B to C, and more. And then it provides a lot of information on the trace. how do we capture that with Daprs? And let's not go in depth with all of these things because it's a little complicated in terms of how do we how do we do this. Just imagine that you want to capture the information of service performance issues with respect to service A to service B and service B to service C. Okay, you want to see that, and if you want to do it with different tools, how it will be. So if you see this instrumenting with Zipkins, right? You will have to change the code. So if you see this, right, you can see you will have to go there, install in Python. This is in Python, by the way. So you will have to install a module, and you will have to do a couple of code changes to it, right? You can see a couple of things you will have to do if you want to use Zipkins without Dappers directly on your application. Okay, so now you see this, right? There's a problem because if I have to do this for 25 applications, there's a Zipkin code I am writing, right? And now my organization decides, okay, we'll move from Zipkin to Aegis. Now the challenge is the same code, same Flask code. You need to change something. The whole code changes, right? If you see the difference between the code, it's completely different code, right? Just keep that in mind. There's a different code there, right? So now the challenge is if you have to move, it's very difficult because as a developer you have to sit and do it, right? And nobody likes to do it, right? And you go and tell developer that you put this trace for your code, they have written code, tracing you do, right? So that's what you're saying. So basically, it's hard to instrument. So that's what I'm trying to tell. So it's hard to instrument something like this without Dappers. And now I remember giving a talk 2-3 years back in RootCon on Eagles, and one of the person asked me how difficult it is to instrument for 25 services, or if I have 30 services, how difficult it is to instrument. My answer was it is very difficult. At that time I answered him like it is very difficult because you have to sit and code. But today I can confidently tell that you don't need to code, you just need to install Dappers and just do some changes to your code and changes to your YAML file, and done, you're here. Okay, so this is what it does. So basically, so there is service A, service B, there is Dapper service A sidecar which gets added to your service A, there is service B sidecar architecture again, and each and every request which is going in between, it is getting collected, and when it is getting collected, the monitoring backend getting enabled. So a bunch of things, right? There is Prometheus, there is Zipkins, and everything is available out there to see what is happening, right? So distributed tracing, I'm not going to spend time on these slides. Let us go and directly see the demo. Okay, so I'll show you the demo. Okay, so I have a cluster of let me connect to my cluster. It's not configured. Just leave it on. Okay, in my laptop. Now, so this is the Kubernetes cluster I have. So I've already built a cluster. Okay, so due to interest of time, the cluster is up and running. So it's just bunch of clicks, next. You have the cluster up and running. It will take some time, so 5 to 6 minutes to bring up the whole cluster. So when I say cluster, it is master, which is already available with the managed by now Azure team, and you have the nodes available now out for you, right? So you can go and enable how many nodes you want and all those things there, right? So this is the cluster I have, and this is the name of the cluster, and this is the resource group of the cluster. And I'll just, okay. So if you see this, okay. So if you see, as of now, my configuration. So kubectl is nothing but a client for, you can see the commands. You can see my commands. Okay. Yeah, kubectl is nothing but a client to connect to the Kubernetes API. In the architecture, you have seen that API was the API server was there, right? And there was a user, right? And user, how does user connect to API server or talk to do some operations through kubectl? Okay. So kubectl is a client. It's just a binary. So there is, I've installed it in my laptop. So there's, I'm trying to see configure the context. I need a context basically to I need to tell my system which Kubernetes cluster to use, right? Otherwise, I will not be able to use. I mean, if I don't know which room to use, there is no point, right? I need to know which room to use, right? So there is, get context. So if you see this command, it is showing a couple of things. So this is not my Kubernetes cluster as of now, right? The context is set to different cluster. There are a bunch of clusters, and I am connected to different clusters, right? So now I want to connect to my cluster. So what I'll do is I'll go and run command. So my cluster name was what? Kubeshow, and what was the resource group? Oh, it is Dapr. Okay. So what I am trying to do, okay. So this is basically what I am trying to do is I'm adding a context, which Kubernetes cluster to work with. Okay. So now we'll go back and run the same get context. Now you see it is now set to Kubeshow. So you can see here star, right? It was not there before. It is now set to Kubeshow, right? Now we will go back and do a couple of operations, which is I have an application, right? We will use that application, and then we will add this application with Zipkin, and the same application we will configure with Dapr, right? So this is what we're going to do. So simple app, simple Azure voting app, and I'll show you just because a couple of them want to see. I open. Yes. Okay, this is the YAML file, right? This is the YAML file. This is the desired state which I was talking about. This is the desired file. Like I want this is how it has to be there. So what I am trying to tell here is there is a couple of things like deployment kind, service kind. There is different set of kind which is there, which is nothing but a controller in Kubernetes. Kubernetes is big. So you need to go and read the documentation and a lot of things, but just for understanding, right? So there is, there is different set of things which you can do, and I'm running Azure port backend service, and if you see this, there's Azure port backend service, and this is the image. Okay. So if you see here, this is the image which is out there. Right? This is the image. So we discussed about images. If you remember, containers and images and this static representation of your code is image. So I am giving the information here. So basically what I'm trying to do is here I'm trying to run a pod and I'm telling which containers to run. That is all is there in this particular YAML file. Okay, and there are a couple of things like this is the limit for the CPU. This is the limit you can use for this particular container, so that it's a proper management of your infrastructure. Okay, cool. So let me go back here and show you the other one, which is the front end. And if you see this code, this is the Azure front end. The other one was back end, right? This is a separate pod. The first pod is the back end. The second pod is about the front end, and this is version 1 of it. And this is the path for the accessing the containers, and this is on the Azure registry. You can use any other registries also for if you want to play around with the code, but this is how you can use it, right? So again, it's all the same, but there are different things which is called as services in Kubernetes, and these services are nothing but you are running a pod, and you have 2 pods, and on top of that there is something called as services, and this is for accessing this pod. Okay, there is pod, there is containers which is running within that, and on top of that there is service which we have defined, and this service is used for accessing the pods. Okay, so take that as there are various ways to access your application, right? One, it could be through load balancer. The other can be in the backend. I don't want anyone to access it, right? I don't want anyone to access it. I am accessing this via load balancer because it is front end. I want to make sure people, everyone need to access this particular application, right? So that is what this whole file does. So let's go and deploy this to Kubernetes. Okay, let's see how it gets deployed. It's a very simple command. Okay, kubectl apply -f. You give the file name. That's it. So you are telling Kubernetes to apply my desired state, and my desired state is defined in the YAML file. I have designed it properly, and I am telling go and execute this within your infrastructure. So now I haven't mentioned where to run it, which node to run it. I'm not mentioned how probably you would have seen I have mentioned only one replication to run, right? And I can also say, okay, run one application now, but when there is a lot of traffic, you can run 10 replications of it, instance of it. You see the code, I show you that just for reference. There is a replication here. You see this? Everybody see? Okay, there is replication is equal to 1. Okay, so the replication is equal to 1 because I just want to run one instance of it, but I can say keep it running as 1, but whenever there is traffic, I can add a couple of more more details there and tell when there is a lot of traffic beyond this, okay, run 10 replications. Okay, so that's how you can design your desired state. That is your desired state. Okay, you're telling that to Kubernetes. So let us go back to the command and we'll apply this. So what it will do is it will just apply it on my Kubernetes cluster. So you see, my code is up and running now in the cluster. So one of the command is to just go and watch it. So we'll just go and watch it. Bunch of things which I'm going to run is in the command. So I like to keep it the count of that. So I just run watch on the cluster on the front end. And you can see there is an IP address which is out there, which is the external IP address, right? So I want to, go and access my application. So I'll go to that IP address. Right? So that's how my application is running. So it's a simple Azure voting app. Whether you like cats or dogs is what you can go and play, right? It's a voting stuff. So now I have this application running. Just note that I haven't done any instrumentation of Daprs yet, not done anything. Now, if I have to build an observability on top of this, that is the Zipkin on top of this, and instrument Zipkin to access the data and see the data, what is happening from the performance perspective, how many requests are coming, and what is the performance of each request. If I have to track that, I will have to go and change the code, right? So that is what we saw in the slide, right? How different it is to change the code, right? But now I'm not going to change any code. I'm just going to use Daprs. I'm just going to run a couple of commands, make changes to the YAML, and rerun this and see that it is working fine. And nothing changes happen to the application, but you will see that information is being pushed to Zipkins. Okay, so let's go and try that out. Okay, the first thing we need to do is to do an init of Dapr. So even before you work with Daprs, you need to have it installed on your system. Okay, you need to go and install Dapr CLI on your system. Otherwise, you will not be able to use the CLI. You need to run something, right? To commands of Daprs, right? This is a simple client, right? So that is, and you need to talk to cluster. So if you go to so if I type Daprs, you will see bunch of things. It has bunch of support. So this is the list of things it can do, right? So there are a bunch of things which you can see, configurations to completions and whatnot. So anyways, I'll not spend time on the CLI part of it. We'll do the init part of it. So Daprs, init, okay. So very important, when you run this command, it is basically checking which cluster context you are in, and it runs everything in that context. Okay. Now, when I say init, what it does is it goes and installs Dapr onto the control plane. What is control plane? Master, right? When you saw that in diagram, right? There is master, right? So when I run this command, it will go and install stuff on the cluster. But before you run this, you need to make sure you have set the right context, right? Your cluster should be right, because you saw my clusters, right? I had five different clusters context within my setup, and I need to make sure that I'm using the right context when I run this command, so that it goes and installs on the right set of Kubernetes cluster. So this is what it is doing now. So basically, it is installing the nothing but the Dapr stuff, right? What are the things it is installing? We will see. So it did install it in the namespace. So a couple of things in the namespace, right? So let us see the namespace. So you can see what you can see here. There is dashboard. There is operator. which is for Dapr. Operator has been installed. So Kubernetes operators are there, different things are there. So you need to understand that. And there is sidecar injector is available out there. So sidecar injector is the most important thing there, right? Because you're going to use now the sidecars, right? So cool. So we have it running. Now we want to make sure we have Zipkins also running, right? Because we don't have Zipkin. By default, we don't have it, right? So we'll go and install Zipkin on my system. So Zipkin is installed, and Zipkin is installed in the backend. So I need to make sure it is clustered. I need to expose it, right? So let us go and expose this port. It is running internally right now on Kubernetes cluster. You can't access it. So I want to expose it, and I'm just exposing it. That's all, nothing else. I want to access Zipkin. So to access it, I'm just exposing it. That's all. Nothing else I'm doing there. Okay. So now the most important thing is we'll go back to the code. Okay. Let's open configurations. Okay. So you can see the configurations here. So this is nothing but how you configure Daprs, right? How you configure specifically building components. There are building blocks. There are components in Daprs, right? So this is nothing but component setup. There is how you're giving. If you see the spec, here, the spec is about tracing. Okay, the code spec is about tracing. So I'm doing distributed tracing. That is the building block. There was a bunch of building blocks. So I'm just using distributed tracing building block in this example. And in this example, if you see the configuration, I'm setting it up as tracing. And you can see there is an endpoint, which is Zipkin endpoint, which I'm setting it up. So whenever you bring up a Zipkin and we install Zipkin, this is the endpoint it will be available on. And we are just going to use that endpoint, and we're going to make sure that tracing is done, and it has been pushing the data, whatever data it captures from a tracing perspective, it is pushing onto the Zipkin's endpoint. Okay, so Zipkin is a tool to capture the data for tracing. To have captured the data, whatever is happening in the request. So it is just storing that request, right? So there is sampling rate. Sampling rate is 1. So it is always between 0 and 1. Whenever it comes to tracing, it is always between 0 and 1. And 1 is obviously it samples all the data. That means any request which is coming into the application, it samples it into the Zipkin. Okay, I can have less as well. Like I can say, okay, 10 set of requests I don't want. I want only only couple of requests which goes into the sampling data, and that's where I can find the bottleneck. So our goal is to find bottlenecks in the performance, right, in the application, seeing where is the performance issue. And Zipkin is helping us to find that, because if you have 25 different services, you don't know where to find the bottleneck. So that's what distributed tracing is all about, right? So this is specifically built for tracing. This is how you build a component, and this is the sampling data, and this is the Zipkin endpoint. Now we have this. All we have to go and do is to set this up, right? So we go and what do we have to do? We have to apply into. It's also a YAML file. There's no difference, right? Both are configurations. Both are user desire, right? The one is the YAML file where the desired state is. This one is also desired state only, because I am giving all the information here. This is how I need sampling rate. This is the endpoint, and right, I am giving it. This is also desired state. So it's same thing as what you do, right? Okay, it also creates the same thing. It just gets created. Right? So we will see configurations -k. So -k is basically on the cluster. So if you see now, again, can you see? So if you see tracing is enabled is equal to true, is it true? You can see this. Tracing is enabled true. Metrics by default it is always true. So metrics and tracing is enabled for not on the application, on the cluster. It is enabled. Applications we have not done it yet. It's on the cluster still. Okay, and you can see the name of it is what? Name is Dapr configuration. So where is it? Where did I name it? It's in the code. It's here. It's in my YAML file. So I have named it. Okay. So this is the name I'm going to use now to configure my application to use Zipkins. Okay. I'm not changing the code. I'm not changing anything in the code. I'm only changing the YAML file. Okay. And we'll go to YAML file now. I'm going to make changes to the YAML file. Just taking. It just moves out. Figure out a different way. Okay, just in case of time, because not using this like this. Okay, so you see the difference in this code. So this is in the backend. I'll start with the backend. There is something called as annotation. This is where you call the injector, the sidecar injector. This is what you do. And this is what you do is like you inject an API into your pod. There is a pod. This is nothing but pod, right? One service is a pod which has one container. This is backend. There is a front end container. It has a one of the pod running. Now you want to run one more container, which is Dapr, where it is injected on top of the container which you are running. And this is how you inject it, right? You just take this, go to the same place in your, just inject. But notice something here. The name is what? What is the name? Dapr config, which is the name which we gave when we installed it on the cluster, right? The same name I'm using it. So it is calling Dapr now. Dapr APIs to be part of this. So if you see the diagram, if you remember, I had shown you there is my service. It is talking to Dapr API, and Dapr API is calling the building blocks, and building blocks is going and talking to the components, right? You remember that slide? The same thing which is happening now here. I'm injecting this, and my application is running, and that is talking to the Dapr API, which I installed it previously from a different configuration file, and now it is running. API is running. Now this is talking to that, and that is sending data to the building blocks, and then components is directly it is connecting to the components. If you remember the endpoint URL I had given in the configuration, that is where it is talking now to the components. So this, if you make that structure in your mind, this is how it is working now. You have the structure here, you're giving the annotation, it is talking to the service, and from there it is talking to the rest of the things. So that's all it is happening here. So it's very simple. I gave just four lines, right? This is 4 lines of code, and I'm taking the same for backend as well. Where is it? I want to take this to line 61, right? And you can see it's on the port as well, different port. I'm given same port where the application is running. Okay, so this is all simple. We have it ready now. All we have to do is to rerun it, right? So even before we run it, what we will do, we will try and access Zipkin. Give it with. Okay, great. So I'll go to local source. One port. No, sorry, which one is that? Is that 941? Added one extra one there. So this is Zipkin. Okay, this is the Zipkin which is running on my cluster. I port forwarded it to access it on my local host. So that's what I've done. So right now the Zipkin is having nothing. So if you see, there's nothing, no trace, nothing, right? Because we have just added, into the configurations of the YAML file. We have just injected it, but we have not run it yet. So this is the state now, right? So we haven't got anything. So we will go there now, and we will run this particular code, which is you see here apply Azure. So if you see now, what did you see?
It's configured.
We changed only deployment, right? We didn't change the service. We just changed the deployment kind. We didn't change the service. So whatever got changed, it says it is configured. But whatever is not changed, it is not configured. Okay. Now to see the Dapr running, what we will do? I'll open the Dapr dashboard, which is running on my Kubernetes. Just remember having case Kubernetes in the command. Okay. So in the command, fnk is always Kubernetes, and it is taking from the context, local context. So we did run how to set context, see context, right? That is the one. So this is Dapr's dashboard. So you see what? The health is good. It shows what? Two different services which is running, two different services running as Dapr right now. That is what it is showing me. And if you see, there's a bunch of things. What are the things? The metadata, which is the address, what is the age, what is the configuration, and what is the configurations we have done, all of this information, the logs, everything it shows. Okay, a bunch of things it is showing me. Okay? And the same thing for from backend and front end is the same, right? So let me show you for backend. You see, it is showing it how it is being used, right? So right now I'll just try and see it is coming. See, you see how fast it was to capture the performance issue of this application. There was no code change. I didn't instrument anything in the code. It was just YAML change. Just added 4 lines for a particular container in the port definition. That's it. Right now I'm able to capture all the data. Right? So if you go back and maybe type in cat dog and keep doing the performance issues, like there are more people accessing it and hitting it, and you'll see in Zipkin that it is going to go beyond that, right? You go and hit query, you will start seeing a minute ago and all those things because the service filters which is here, this 10, last 15 minutes, millisecond, whatever, last 1 minute. Let us go for last 2 hours. Just right. So if you see this, I was able to see what is the performance, and you see this particular request has taken a lot of time to return. Right now, I go and see this and see there is a couple of things. What is happening here? What is the output? Why it is taking? So in trace, you will see what all other services it has been touching and other things. As of now, I don't have much of microservices, so you don't feel okay. What is it? What is happening here? But if you have bunch of microservices and bunch of microservices being touched, you will see there is bunch of things you can see there. Right? So you'll see the performance issues, all of those things within Zipkin. Now, if I have to convert Zipkin into the Agos, how will I do? Now, I had an application. I wanted to instrument Zipkin. I used Dapr. I instrumented it. Fine, Zipkin is working, all fine, good. I'm getting data, is fine. My organization decides to move from Zipkin to Agos. We will go cloud native, use cloud native CNC foundation tool, and not go with Zipkin. We'll go with standard. Let's go and use standard. Now, if I have to change this, if it was code without Daprs, it used to be, it's going to take a lot of time to do it for more than 25 servers. Like you have to go and instrument it in the code. But for this, what I'll do? All I have to do is to change the endpoint. All I have to do in this code, in the configuration file, we did this, right? We did sampling rate, we gave the name, we gave some name, and we did mention the spec is equal to tracing, and we said it is Zipkin. Now we said, okay, no, I don't want Zipkin, I want to go for Agos. All I have to do is to come here, change the endpoint to Agos, have Agar installed on my Kubernetes cluster, done. No code change, nothing.
So it will be coming through Zipkin or what?
No,
Because
endpoint is changed to Agos. If you see here, I'll show you configuration for. So here it is Zipkin. Now this is having a problem. You can see this is Zipkin. Now it is Zipkin. Now, if I have to change this, I'll go and make change to endpoint, rerun the Kubernetes apply, and I have this up and running. What I have to make changes, where I have to make changes, if I have to use Agos and stop Zipkin, is I'll go to my app. What I should give here? Tracing. Because the name of my configuration is tracing. If you see here, the name is tracing, right? So there is name tracing. I'll go to my YAML code where I have mentioned Dapr configure, which is for Zipkin. I'll just make changes to that and I'm done. It is using Agar as a different tool. Similarly, I'll go back to my slide again. Where's my slide? Oh, not this one. So this is supposed to be the tracing one. If you want to understand in depth with tracing, right? Let me go back to my slide. This one. Similarly, I did it for observability, right? I went and configured for observability the Zipkin to Agar. If you see, Agar is one of the component and Zipkin is one of the component. I can use both. by the way. I can push data to both. Okay, now you can see you can instrument the same thing with PubSub. You can instrument similarly with secret management. So all of these things, just trying to fix this now. Happens in fix this. Anyways, let's see. Forget it. So there is there are a bunch of things, right? If you want to do that, you can just go and instrument the same way I have instrumented. Take a configuration file, provide the spec for that, add a spec as tracing and add a spec as PubSub. All of these things are available out there in the documentation. What you need to add, just add it. Just use the endpoints, write endpoints, done, and just inject it in your application. You are able to get the data. Okay, so that's what that's what Dapr is, and a couple of things.
Retracing is also possible then.
Huh?
Retracing is also possible. We just have to remove that endpoint address and the name from there. That file.
You don't need to do that. You can add both together as well. You can add both together.
But what if that is not being used?
What is not being used?
Again, you just Eager is not being used later on, and again we have to move to Dipkin. Then again we will have to follow the same step.
So you can, as I told you, you can use both.
Yeah.
Unless and until you feel freedom of using different things, you can send data to both.
And same applies on service to service basis.
Yes. Depends. I mean, because those are used for very different things. Observability, you can use both. But probably when you are managing the state, probably both is not a good idea, because having it stored in one place is good, and not to verify two different things, right? But Jaeger and Jenkins, it does the same thing. It doesn't use different things. And Jaeger is built on Jenkins, so it's not like different things, right? So yeah, so basically this is a nice book. If you want to learn more about Jaegers and all the building blocks, and want to learn about and play around with it, and want to learn more about how to use Daprs and solving amazing microservice problems, you can go through this book. It's for .NET developers, by the way, but it's fun to build it on anything. So you can go and make use of it. This is a link. Take a look at it. So that's something which I just wanted to talk about. Any questions? People who are online, any questions you have? People who are here, any questions?
They have multiple containers. Yeah, if I have multiple containers, should I need to do this configuration Dapr, inject Dapr for every container, or automatically it will be taken care?
This is for each pod.
Each pod.
This is for each pod, yes.
If there are multiple pods, then we have to.
Yeah, multiple. I did it for multiple pods. If you see, one pod for backend, one pod for backend. I had one single file for one YAML file both. But in a real world, probably would separate out these YAML files, right? So that's one thing. And there is a question in the, I don't know, it's a question. I think it's the steps which has been mentioned, like install another APM, modify Dapr configure, and modify application YAML. Yeah, that's what it solves. So you need to go and try it out and see how exactly it injects into your RabbitMQ without making any code changes to it. There is a question like, usually they make changes to the code from a Rabbit. Yeah, it is amazing. Even I was surprised because I remember doing instrumentation of tracing with Zipkins, and for Jaegers, in fact, I did instrument code to build demos and other things. So I know the pain, right? So it is surprising that without doing all of this instrumentation within the changing the code, you can see all of this data. So it might be surprising for you if you go and try it out for RabbitMQ as well. No, you need to make it instrumentation in the code. Code you need to do. That's what it says. Yeah. As I told you, right? As 2 years or 3 years back when I was doing in RootConf and I was talking, somebody asked me this question. I said, yeah, it's hard. But today I'm happy to say it's not hard. Dapr is here and you can easily use it. Right. So that's the whole point. Cool. If you have any questions, people who have joined online, you can just reach out to me and ask me questions. And we can obviously chat about it. As of now, we're going to stop recording and we're going to stop the online, hybrid thing, which has been streamed right now. So if you have questions, you just reach out to me, and I'll be happy to answer this questions, any questions you have. But we'll just take a break now.
Thank you,
Thank
Vivek,
you.
for the session.
Okay, go ahead.
Thank you, online audience, for joining us. Please do share your feedback and please use the Learn module. What Vivek has shared, it will give access to your additional resource and take your learning further. Thank you. Please also visit our Microsoft Reactor Bangalore page, meetup page, for more upcoming sessions. And thank you and enjoy the rest of your day.
Okay.